Dear students, in today's video, we will learn two important theorems in geometry of chapter Quadrilaterals. The first theorem which we are going to learn is the theorem of midpoint of two sides of the triangle, and second theorem which we are going to prove is the converse of midpoint of the two sides of the triangle. So let us prove the theorems. Theorem of midpoint of two sides of the triangle. So statement of the theorem: the segment joining the midpoints of any two sides of a triangle is parallel to third side and is half of it. So there are two parts in this statement. First is the given part and second is to prove. So here the given part, let us consider in triangle ABC, point P and point Q. Point P is the midpoint of side AB and point Q is midpoint of side AC. We have to prove that this segment PQ is parallel to side BC, and second part we have to prove that this length PQ is 1/2 the length of side BC. So here we have to do one construction. Produce the segment PQ up to R such that PQ is equal to QR. This PQ and QR are congruent. Draw RC. Draw joint RC. Now here we get two triangles, triangle AQP and triangle CQR. These two triangles, let us consider proof of the theorem. So in triangle AQP and triangle CQR, in these two triangles, first PQ, segment PQ is congruent to segment QR. By construction, we have done the construction, they are congruent. PQ is congruent to QR. Then segment AQ is congruent to segment QC, that is given part. Segment AQ is congruent to QC, which is given. Then angle APQ is congruent to angle CQR. These are the APQ. Angle APQ is congruent to angle CQR. These are the vertically opposite angle. APQ is congruent to vertically opposite angles are congruent. Therefore, triangle APQ is congruent to triangle CQR by side angle side take. Two sides are included. Angle of one triangle is congruent to two sides and included angle of corresponding another triangle. Therefore, these two triangles, triangle APQ is congruent to CQR by side angle side test. Once two triangles are congruent, their corresponding sides or angles are also congruent. So here angle PAQ is congruent to angle RCQ. These two angles are congruent, corresponding angle of congruent triangle. Statement number first. Then segment AP is congruent to segment RC, that is corresponding sides of congruent triangle. So from now on, now this AP is congruent to CR. This angle PAQ is congruent to angle RCQ. These two angles are congruent. If we consider AC as a transversal, AC is the transversal, then these angles are alternate angles. And if alternate angles are congruent, so by alternate angle test, line AB is parallel to line CR. Line AB is parallel to line CR. So these two lines are parallel. So here, but from 2, AP is equal to RC. AP is equal to CR from 2, statement number 2. But AP is equal to PB, it is given, and then this is equal to RC. So AP equal to PB equal to CR. All three sides are equal. So this PB is equal to CR So these are the opposite sides are parallel as well as opposite sides are congruent. Therefore, the quadrilateral in PBCR. Therefore, quadrilateral PBCR opposite sides are parallel and pair of the opposite side is congruent. So it is a parallelogram. Therefore, PQ is also parallel to BC. Therefore, if one pair is a parallelogram, quadrilateral is a parallelogram, its opposite sides are parallel. So BC and PR is equal to BC. PR is equal to BC. Opposite sides of parallelogram are congruent. Therefore, PQ is equal to 1 half. PQ is half of PR. PQ is half of PR, but PR is equal to BC. PR and BC are equal. Therefore, PQ is equal to 1 half BC. PR and BC are equal. So, PQ is equal to 1 half BC. Hence, we have proved it that PQ is parallel to BC and PQ is half of BC. Hence, we have proved the midpoint theorem. Converse of midpoint theorem. The statement of the theorem is, if a line is drawn through the midpoint of one side of a triangle and parallel to the other side, then it bisects the third side. So, there are two parts here. First part is, if a line is drawn from the midpoint of one side and parallel to the third side, then the triangle is parallel to the third side. It bisects the third side. So, let us consider the given part. In triangle ABC, let point D be the midpoint of side AB, which is given, and line L is passing through point D and parallel to side BC intersect side AC in point E. We have to prove that this is also the midpoint. E is also the midpoint of AC. Means we have to prove that A is equal to EC. We have to prove A is equal to EC. So, construction, take point F on line L, take point F on line L such that D dash, E dash F and DE is equal to DE is equal to EF. Joint FC. Now, in this figure, by construction, CF is parallel to AB. CF is parallel to AB and line AC is the transversal. Therefore, by alternate angle test, angle DAE, angle DAC is congruent to angle FCE. These two angles are congruent. These are the alternate angles. Angle DAC is congruent to angle FCA by alternate angle test. That is, angle DAE is congruent to angle FCE. That is statement number 1. A dash C. Now, let us consider the quadrilateral DBFC. In quadrilateral DBFC, DF is parallel to BC. It is given DFL is D is parallel, means DF is parallel to BC, and side BD is parallel to CF. By construction, we have done the construction, these two are parallel. Therefore, quadrilateral DBCF is a parallelogram. So, by definition of parallelogram, the opposite sides of the parallelogram are congruent. Therefore, DB is congruent to FC. DB and FC are CF are congruent. Also, AD is equal to BD. This is given since D is the midpoint of AB. This D is the midpoint of AB. Means it is given that this DB is congruent to is equal to AD. Statement number 3. So, from 2 and 3, DB is equal to CF. Statement number 2, and DB is also equal to AD, which is given. Therefore, from 2 and 3, we get here that CF is congruent to AD. CF and AD are congruent. CF is congruent to AD. Statement number 4. Now, in triangle ADE, and triangle CEF. In triangle ADE and triangle ADE and triangle CEF, these two triangles, angle DAE is congruent to angle FCE. From one, here we have proved it. These two triangles are from one. These two angles are alternate angles. They are congruent in these two triangles. Then segment AD is congruent to segment FC. So from statement number 4, CF is congruent to AD. Then angle, one more angle, angle AED. Angle AED is congruent to angle FEC or CEF. These are two vertically opposite angles. Vertically opposite angles are congruent. FEC, vertically opposite angles are congruent. So these two triangles are congruent by triangle ADE is congruent to triangle CEF by side. One side, this side is congruent to this side angle test. Side angle test. Therefore, A is equal to EC. Therefore, A is equal to EC. Hence, corresponding side of congruent triangle. Therefore, AE and EC are equal. Therefore, line L is it bisect line L bisect side AC. So line it bisects side AC.